OABC is a parallelogram. So that means that the vector from O to A will be the same as the vector from C to B. So this is A over here. The vector from A to B will be the same as the vector from O to C. So this one's B. We're then told that X is on the line AC. So let's draw that line AC in here. And X is on that line such that A to X is 2 parts and X to C is 1 part. So because the X to C part is smaller, that means that X is closer to C. So I'm going to put X here, where the X to C, that is 1 part, and the A to X part, this part here, is 2 parts. We're then told that OCD is a straight line. Well, we can see OC is here. So let's mark on point D over here somewhere. So here's the line OCD. Such that OC to CD is K to 2. I'm writing that out separately because it's the K that I want to work out here. Now we know that OC, that's vector B, so I know that already. I can write that here. It's the C to D part that I don't know yet. So I want to work out what this C to D is. Then I can compare these two and hopefully work out what C is. So C to D is this vector here. And I can find that because they've told me what the X to D vector is from here to here. They've told me that that is 2b minus 1/3 a. So I can now say that C to D, this vector from here to here, is going to be the same as C to X plus X to D. We're going from C to X plus X to D. That is the same as going from C to D. So C to X plus X to D. Now the C to X vector, we know that this is 1/3 of the whole C to A vector. So C to X is 1/3 of C to A. What's the C to A vector? Going from here to here. Well, I could go from C to B plus B to A. Now the C to B vector, that is going in the same direction as vector A, so that's a positive A. But the B to A vector there, notice that's going in the opposite direction, so that's going to be a minus B. So we've got a positive A and a negative B. And C to X is 1/3 of that, or 1/3 A minus 1/3 B. So now we know what C to X is, I can put that here. And we're adding the X to D vector, which we know we were told that is 2b minus 1/3 A. Now I'm going to collect up some like terms here. I've got the 1/3 A minus 1/3 A, so they're going to cancel out. And then I've got the minus 1/3 B plus 2b. So the 2 take away the 1/3, 2b take away 1/3 b. Well, 2 is 2 over 1. Well, that's the same thing as 6 over 3. So So 6 over 3 take away 1 over 3 is 5 over 3b. So that is the C to D vector that we were looking for. So now I can come up here and now I can compare these two equal ratios. So looking at this side here, I could divide both sides of that ratio by the vector b, because there's a b in both of those. Dividing the left-hand side, I get 1. Dividing the right-hand side, I get 5 over 3. Now, in order for me to work out what k is, I'd like this side of the ratio to be equal to 2, so I can compare them nicely. So I want to take this and turn it into a 2. Well, first thing, if I times both sides of this by 3 to get rid of that fraction, I get 3 to 5 is equal to k to 2. If I then divided both sides of this by 5, I'd get 3/5 to 1 is k to 2. And then if I times both sides of it by 2, I get 2 to 6 over 5 is equal to k to 2. And now this is 2 and this is 2. They are equal, which means the left-hand sides of these must be equal as well. So k is equal to 6 over 5. And there we go.